Okay, so we are using the iris dataset for our analysis. So these are the steps in EDA. You provide descriptions for your sample, you check for missing data, identify the shape of your data, significant correlations, and dealing with outliers. Okay, so there are two ways in loading the iris dataset. Iris dataset is basically an inbuilt dataset. So you can directly import it by using sklearn. And if you have a file, you can simply load and you can start the cleaning. So this is the information about the iris dataset. So if you want to know information about iris dataset, you can simply use this code and you can simply load the information. And this is how the iris dataset will look. And here we loaded the iris data in a data frame, and I'm checking the first 5 rows. So when you use df.head, it will give you the first 5 rows. And in the parentheses, if you mention like 10, you will get the 10 rows, and 20, you will get the 20 rows. So just to see how the data will look, basically we will prefer df.head and providing descriptions for your sample. So in this, we will discuss how many rows and columns. So df.shape, 150 and 6, and df.info. It will give all the information about your data. And df.describe to get the descriptive statistics of your data. And isNull.sum. So if you observe isNull.sum, there are no null values. The count is 0. And drop duplicates. So if there are any duplicates, we can drop that. And so this is basically used to get how many unique columns are there in your species column. And next is our dataset balanced. So this is the code to check how your data is balanced. And we are checking for missing data, isNull.sum. So, and this drop any and drop duplicates. So when you do this, like it will clear everything. It will drop the null values. It will drop the duplicates. And df.info. And next. So as type, we discussed in previous classes, df.as type. So if you want any column in your preferred data type, you need to use as type. So here we are using float so that the petal width will be in float. And visualization, so we are importing the packages. We are using Seaborn and Matplotlib. For visualizations, you are using Matplotlib. And plot.show. So when you click on plot.show, this is the plot that we are getting. And this is the relationship between variables. So we are plotting the scatter plot for the single independent variable sepal length and the independent variable, like dependent variable sepal width. So this one, and this is simply the strip plot and the violin plot. And this is the pair plot that we discussed before. And histograms. So if you run this code, you will get the histograms and correlation. This is the heat map. And detecting and removing outliers. So when you plot this for your columns, so you will come to know like how outliers will show for each column. And this is the box plot. And yeah, so this is the formula to calculate the upper bound and lower bound for the outliers. So if you have a box plot, you will have Q1, Q2, Q3, and by using this, you will calculate upper bound. And by using this formula, you will calculate the lower bound. And you will remove the outliers which are greater than upper bound and which are greater than lower bound. And that is the method to remove the outliers. And yeah, so simply in your free time, if you have any doubts, you can just go through this code. And if you have any doubts, you can reach out to me in Blackboard. Next. Okay. Okay. So now there is a short lecture related to variance inflation factor in brief. So variance inflation factor is related to multiple linear regression. Second. Okay. So VIF, basically we need to discuss about VIF because we are dealing with the correlation. The thing is, in multiple linear regression, we will consider many variables, and the target variable will be a single one, but the independent variables will be many, like x1, x2, and x3. So, and based upon the correlation, we are like identifying the target variable, right? Like based upon the independent variables, we are predicting the target variable. So the thing is, here we need to understand how two variables are correlated such that one does not influence, like one should not influence the other. By using VIF, we can understand how to how two variables are highly correlated. Because if they are highly correlated, there is a chance that one is showing high influence on the target variable compared to other. And next, like true dependencies are basically impossible. Features that can vary together are called collinear. And these values are strongly correlated, whether positive or negative. VAF is a best way to measure multiple collinearity. And imagine we are building a MLR, multiple linear regression. I think most of us will build MLR because we are not trying to uh, predict the target variable based upon a single variable. And we want to include the most useful features, generally the one that most strongly predict the target and the one that have low collinearity with other features. Because whatever the variables that you are selecting, it should have relation with the target variable, not with the other variables. So that is the point that you need to consider while building the model and also while selecting the variables. And the one that when excluded from the model significantly worsen it. And we want to exclude the useless features. So which features are not related to your target variable, we need to simply ignore them. So the one that don't change much and the one that don't correlate with the target. So this comes under the features that are not related with the target variable. So here we used 4 feature variables to see if we could predict species. We generated scatter plots, correlation table, and heat map to compare every pair of features. So if you observe sepal width and sepal length, there is a weak negative correlation. And petal width and petal length, there is a strong positive correlation. And sepal width and petal length, there is a moderate negative correlation. So like so if you want to measure everything all at once, we are going to use VIF. So VIF is a metric for measuring multicollinearity. Like for example, if you consider there are n features, so these are the features in the IDs, and you calculate a linear regression for each feature using the remaining features. Like for example, you are predicting the sepal width based upon these features, and you are predicting the sepal length based on width, like sepal width and petal length and petal width, and you are predicting the petal width and based on other variables. So let us say we use a metric that is R square. I said like correlation is denoted by R and variance inflation factor is nothing but to decide like which is most or least explained by the others. So for each feature, this is the formula. So if you have the correlation and we are squaring that, and this is the formula to calculate the VIF 1 divided by 1 minus R square. So there are some certain values like good and bad. So if VIF equal to 1, R square equal to 0, that is zero collinearity. So if you observe two variables, like here I'm not talking about the relationship between a variable and the target variable. I'm talking about the relationship between two independent variables. So here if VIF equal to 1 and R square equal to 0. So if VIF is like greater than 1 and less than 5, and this is the R square values, it is pretty good. So low to moderate collinearity. And this is the, if you consider the range between 5 and 10, not so great, high correlation depending on the model may want to exclude. So based upon these values, you can decide which variables you can include or which variables you can exclude. And if VIF is greater than 10, so you should definitely should not include that variable. So make sure you remember these values while building the model. Okay, that's all. Okay. Oh, it's only 10. Okay. So any doubts related to like correlation, EDA, because you are going to do a homework on EDA. And okay. Any doubts related to data cleaning? I think Monday is the deadline for data cleaning. So yeah, yes.
All that in the iris data set.
Yeah.
With the box plot.
Yes.
Right, when box plots all together, we see some outliers.
Yes.
Separate the species out, those outliers are no longer outliers.
Okay.
That's a kind of a great classic example of that.
Mhm.
If you're starting to look for outliers in your data, you look at it both in terms of conglomerate data and in the specific categories that you're assigning, because the iris data set, of course, if we start eliminating outliers, we actually eliminate legitimate variables or observations for Setosa and versicolor or virginica that are not outliers for that species. They're only outliers when you conglomerate everything together. It's all there.
Okay. So I think so we ended up early. So if you have any doubts relating to the homework or project, we can discuss. Yeah. It's related to homework. Exact. Okay. Let me check. Yeah, yeah. I will open that. 1 second.
Yeah, one state did ask on that big homework.
Mhm.
Do you want me to do the homework in the IPython notebook, not in a Word document or anything? We have to look at some things and, for what things need data cleaning, stuff like that, right? And so just go ahead and create a markdown cell or a raw cell in the IPython notebook. Put that in there.
I will open this so that everyone last.
That was done. Thank you, so. Asked before class this morning.
Oh, just a second. So this is what you're talking about. So this is the code to do the data cleaning. Could you ask your doubt again so that I can understand?
We are going to the extra step. Those are the tasks, right, that you need to complete.
Yes.
Top I mentioned.
Yes.
So you didn't mention anything like add extra steps for game. Just mention identify problems and.
If they want.
Yes.
Yeah.
Go back to the top of the instruction there.
Yeah, here.
So.
If they want.
So, yeah, so step forward, list of problems you found, that's the markdown cell. Step 5, take a mark in that markdown cell, right, how you're going to clean up those problems. What do you think you're going to do to clean them? What's the best way? I'm going to just throw them away, which is the easy way for this homework. Or if you want to be clever and like, I'm gonna plug in the average value for this column in this field, right? So I'm gonna fill it in with random, who I think is a good missing value. You can do that too. It doesn't matter for this homework, it's just throwing the techniques in there. Then in step 6, it is actually clean the data problems up. That is, put in a code cell and do the work to clean it up after your markdown, okay? And then now the question is, look at the basic statistics again, more cells at the bottom of the code. Does your data look good? Is there still something funky looking in it? Are you still seeing null numbers? Did you somehow fail to catch something and not drop a null field or something like that, right? So, and then go back and just kind of keep adding things in until you have a code that just goes clean. And that's all working in the same thing, of course. You're just doing it repeatedly until you have code that just flies, smoothly go through. Here's the problems I identified. To identify more, just add them to the bottom of that same cell, and so on and so forth, right? You don't have to be out there saying, make multiple cells, every problem I find gets its own cell. No, you don't put them all in there. So one cell where you have problems, another cell maybe below it where you say, this is how I'm going to clean these up. And then the cell below that where you actually clean it, and then 3 or 4 or 5 cells below where you visualize it and have clean data. Eventually
The problem is they can't write down the updated.
Yeah. So then, So you're adding all your code at the bottom, and you're just going to say, here's because code as is, you just run it, you'll get a picture of what's missing,
Yeah.
and so on and so forth. So then just start cleaning it up. Some data. Well, I'm sitting here in my chair doing this without the microphone.
Okay.
You can repeat.
So which one?
Are we recording?
Yes.
Stop. Yeah.
So, okay, yeah, so, I'm sorry, I should have been talking on the microphone all this time. So, yeah, so on the homework, you're going to do the work in the IPython notebook. You're going to go down, you're going to run the code as it is. Sometimes there are error types that cause the code that's already in there to break and not to run. For instance, if you were to load the iris data set, like we have on the example in today's lecture from the sklearn data set, and then try to use that data set, it would break. This code is designed to use this comma separate values file, right? So as you find issues in there, you'll fix them. Sometimes your code will abort just because of the way we've written it. I'm not sure that'll happen in this case. I haven't run it, but I think it's okay. I think everything will run. So you run the code, you look at the errors, you see what the errors there are. You list out the errors you found in a cell below that. And then in the cell below that, you make another one. You say, for these errors, 1, 2, 3, 4, this is what I plan to do. And then next below that is you're going to go ahead and have a code cell where you clean the problems up. And then below that, you're going to go take the code that you've cleaned up and add add extra cells in there to do the visualizations and the shape of the data and things like that, and verify you have no more nulls and things like that in the data. So run the descriptive statistics to show that you've cleaned up the problems that you found. And if you don't find every problem in the code in the data set, that's okay. I think there's a lot of fairly obvious ones that I put in there, which is kind of do what you have time for. Yes. Yes, you can put comments right in the code blocks. Yes, if you want to do that too. Yeah. It'll be easier for us to grade. So we'd prefer it if you would just have, for just the things about, this is my list, this is the things I'm going to do. It would be easier for us if you would use a couple of markdown cells or raw data cells, just so we can find at the bottom, right? So instead of going back there and changing the stuff that's in there, you should be able to just run the stuff that's in there and add everything that's new at the bottom of the thing. And if you want to put your comments in code blocks at the bottom, that's fine. If you want to put it in markdown, that's fine. It's just, leave the code, the stuff that's in the file existing as is. I will go ahead and post an announcement about that. Yeah. Okay. I think we're good. Any more questions? Documentation. It's a simple,
No, it's a simple. You just
simple cook. Yeah. So
submit the ipynb file.
Yeah. Have you ever heard of literate programming? Literate programming is programming like you're writing a book, to where you don't have to write documentation because the code itself is so well written that someone can just sit down and read it and it documents itself. And you can do that with Python. You can give it great variable names, you can space things out, so on and so forth. I encourage everybody to use that kind of style of programming, even though I don't do it myself, because I'm ancient and I learned the old bad techniques back in the old days. But you know, if you try to program in a way that you think about looking at it as someone looking at it that has never seen it, it's useful. So yes, documentation, but no, you don't have to have it special in this case. Okay.
Done.
All right.
Okay. Now I will discuss about project. Marcus. Fine. Okay. So I think everyone got the data sets right. I think so. Yes. Okay. So, okay. So what is the next step? I know everyone needs some time to understand the data set. So look at your data carefully and try to familiarize with the terminologies used in the data set. So as I said before doing the data cleaning, first understand the data, take some time to understand the data. And go through various research papers done in this area to get with the work being done in this research area, and think what needs to be done with the data in your hand and try to enhance the data if needed. Like if you think that I need to add some more data so that the further steps will be easier for me, so you can definitely add that. So there is 2 weeks of time to understand everything. So you are not going to submit anything related to the project next week. So you have 2 weeks of time for the next next assignment. So this is the next submission. These are the requirements you need to do. You need to prepare a document for the submission. So page 1 is the cover page, like topic name, student names, and WSU IDs and logo, like whatever you did in the first part. And 2 is the content, and 3 will be the end. So there are 3 pages. So please submit 3 pages. In the previous submissions, we asked like a 2-page submissions, but some students they did only 1 page. So make sure you follow the rules. Like if he said we needed 3 pages, please submit 3 pages. And few paragraphs about the topic, like why you picked the topic. And next, background. So you have the topic, you have the data sets. So I think you can definitely write the background by referring to some research papers. And cite all the scientific papers studied and the background work done till now. And study more scientific papers and understand how they mention this section in their work. And about the data set, explain everything about the data set you have along with the Jupyter notebook files. So good visualizations are greatly appreciated. Okay. So we are planning to give the EDA homework on the project datasets so that whatever you've done for the EDA homework, you can use most of that stuff in your document so that you can submit for the project too. So this is the requirements for the document, like future work, explain what you want to do, like in the future with your data, type of models you want to build, and what you want to use your specific models. And references, make sure you cite all your references in APA format. Okay. And mention all images, tables, formulas with numbers, and mention all of those in your content. Example, figure 1 says how rainfall incremented in the last 10 years. Do not keep citations without references, and references can be verified occasionally and points will be detected for irrelevant citations. So make sure what you cite is related to your data. Keep an eye on the formatting of the document. Points will be detected for unprofessional formatting. So simply just understand the data set and write the background research and the images, figures, and the citations, and make sure you cite the references in APA format. So the deadline is on 23rd. So you have 2 weeks of time and you are doing EDA homework in middle. So it will cover some of your time so that it will reduce some work related to your project. So just go through these slides before starting the document, because once you start the document and you don't follow the rules, it will be very hard for you to cover everything at the end. Okay, that's all for today. Any doubts related to the project? If you have any doubts, just you can mail me in the Blackboard. Okay, we are done for today. Okay. No, it's a document, 3-page document. So make sure you submit 3 pages. Okay. And that's all for today. Thank you for listening. And now I will go for the attendance. I will stop sharing. So Professor, do you want to give grade for the people in the online, like attendance today? Oh, okay, okay.